So the next thing we're going to look at today is what's called the least common multiple, or sometimes just abbreviated as LCM. This is probably the way you'll see me write it most of the time. The least common multiple is the number that if you take two numbers, it's the smallest number that is a multiple of each of those. So that's kind of confusing just to say, but let me just show you an example. For example, if I take 6 and 4 as my two numbers, I want to know what is the smallest number that can be divided by each of these numbers. So a number that can be divided by a number is what's called a multiple. For example, multiples of 6 include 6 because 6 divided by 6 is 1. 12 is a multiple of 6 because 12 divided by 6 is 2. 18 can be divided by 6, 24 can be divided by 6, 36, so on and so on. So you can actually have an infinite amount of multiples. You just keep multiplying them out. For example, this is 6 times 1, 6 times 2, 6 times 3, etc., etc. We can do this forever. The multiples of 4 are 4, and then 8. 8 divided by 4 is 2. 12 divided by 4 is 3, and then 16, and then 20, and so on. Again, the way that I got these is I just said 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. Now, what I would like to find when I'm looking for the least common multiple is what is the smallest number that both of these multiples have in common. Both of these numbers have in common as their multiple. In other words, what is the smallest one of these numbers that exist in both of these lists? For example, 4 and 8 are small, but they don't exist in this list up here. The smallest number that exists in both lists is, in fact, 12. So we'll say that the least common multiple of 4 and 6 is 12. It's the smallest number that is divisible by both of these. As you can imagine, least common multiple should be somewhat intuitive as you're working with the numbers. We will look at a quick way to come up with the least common multiple if you're not 100% sure. Once you do a lot of these, you'll kind of start getting the hang of it. Hopefully, become pretty easily. I wanted to mention that the least common multiple is not the only common multiple. For example, 24 is divisible by 4 and it's divisible by 6. 24 divided by 6 is 4. 24 divided by 4 is 6. So 24 is a common multiple of 6 and 4. However, it's not the smallest common multiple. And that's what we're looking at here when we're looking at the least common multiple. We're looking for what is that smallest number. So how about the least common multiple of 3 and 5? Okay. Now, if you notice, 3 times 5 is 15, and that is a common multiple. In fact, if you multiply the two numbers together, you'll always get a common multiple. The question is that the smallest common multiple? Well, the multiples of 3 are 3, 9, oh, sorry, missed one. 3, 6, 9, 12, 15, 18, 21, etc. The multiples of 5 are 5, 10, 15, 20, 25, 30, etc. You can see that there is a smallest number that exists in both of these lists. We've already found it. It's 15. So in fact, the least common multiple here is going to be 15, which is kind of what we thought initially, but we had to go through and make sure that there weren't any multiples that were smaller as we listed out our multiples. Now, it is possible that if you have two numbers and you're trying to find the least common multiple, that the least common multiple will actually be one of the numbers. For example, between 4 and 12, 12 is a multiple of 4, so if I'm looking at the multiples here of 12, I get 12, 24, 36, 48, etc. Well, the multiples of 4, 8, 12, 16, you'll see that 12 pops up in this list, in both of these lists, so that means that the least common multiple of these is 12, but that's one of my original numbers. That's totally okay, because since the number itself is a multiple, because if you multiply by 1, you get back to the number, it's okay for that to be the least common multiple between the numbers. For smaller numbers, this becomes pretty intuitive. Hopefully it's not too hard for you to find these least common multiples. For larger numbers, it can be a little more difficult. What is the smallest multiple that exists for both of these? So we do have a method for doing this, and I'll show you what it is. Let's take a still not too bad example. Let's look at the least common multiple of 12 and 20. So if I'm not 100% sure what the least common multiple here is, I know if I multiply 12 times 20, that should be a multiple of both, but is that the smallest one? Well, the easiest thing, or the most efficient thing, I should say, to do, is to take both of these numbers and write them out as a prime factorization. For example, the prime factorization of 20 is 2 times 2 times 5. Prime factorization of 12 is going to be 2 times 2 times 3. And then the way we can find the least common multiple of these two is to, first of all, square off any of the multiples that are different. Sorry, any of the factors that are different, so 5 and 3 are different. Any factors that are the same, we're going to lump them together like they're one number. Okay, so the two pairs of 2 get lumped together. Now we just take each square as its own number. So this square gives me a 2, just one of them though, only take one of the 2's. This square also gives me a 2. This square will give me a 5, and then this square will give me a 3. And we just take all of those numbers and multiply them together. So 2 times 2 is 4, times 5 is 20, times 3 is equal to 60. So 60 should be the least common multiple of 12 and 20. So that does give us a pretty efficient way to figure this out, if it's not very obvious what the least common multiple is. Let's try this with a different number. So maybe we'll keep the 12, but change the 20 to a 40. So what is the least common multiple of 12 and 40? Okay, we're going to do the same thing. I'm going to take 40 and 12 and write these in their prime factorization, into their smallest prime number bits. So 40 will be 2 times 20, so if I want to figure this out, 40 is 2 times 20, and then 20 will go to 2 times 10, and then 10 will go to 2 times 5. So the factorization of 40 is 2 times 2 times 2 times 5. 12, we already did this one, we know it's 2 times 2 times 3. Now again, the first thing I'm going to do is square off any numbers that are different, that don't exist in both lists. So the 3 and the 5 don't exist in both lists. And then pair any numbers together. So the 2 and the 2 pair together, and the 2 and the 2 pair together. However, this 2 does not have a number to pair with. So it gets a square by itself, because there's nothing for it to pair with down here. And again, the idea is that every square accounts for one number whenever we go to multiply everything back together. So I'll get 1 2 from here, 1 2 from here, a third 2 from here, a 3, and then a 5. And that should be my least common multiple. So I get a 2 from this square, a 2 from this square, a 2 from this square, a 3 from that square, and then a 5 from that square. When I multiply all this out, I get 2 times 2 times 2 is 8. 8 times 5 is 40, and then 40 times 3 is 120. So as you can see, you would have eventually been able to figure that out if you just did the list of factors of these guys. So if you kind of did it the old way that we were doing it before, you would eventually got there. 120 would have shown up somewhere on the list. The same thing with 40. And in fact, it shows up pretty fast on 40. And you would have eventually gotten these two. But once the numbers start getting bigger and bigger and bigger, it becomes longer and longer to do this. So if I gave you, for example, the least common multiple of 165 and 3,283. All of a sudden, this task of listing out multiples becomes very boring and monotonous and takes a long time. So if you can shorten the process by doing the prime factorization and multiplying together. And in fact, this is how a computer, I imagine, would do this most of the algorithms. This is a good algorithm that you could make a program to do, and it would automatically find the least common factor for you. So let's try one more quick one. So how about the least common multiple of 65 and 32? So again, this is one that if you were trying to do this by hand and just go through, it might take you a long time, so we're going to use our trick here. I'm going to take 65 and write it as a prime factorization. Let's see, I know that 65 should be divisible by 5. Okay, and in fact, it's just 5 times 13. So we'll write that here. And in fact, I want to, let's start over. I want to make one that's a little more interesting. Let's make this one, instead of 65, 120. Or I should say, let's do 130. Okay. So let's start over here. So 130, it's prime factorization. It definitely factors into 2 times 65. And then 65 will continue to factor into 5 times 13. So the prime factorization of 130 is 2 times 5 times 13. The prime factorization of 32 is going to be 2 times 2 times 2 times 2 times 2, which is 5 times. 2, 4, 8, 16, 32. The reason I wanted to do this one is I wanted to have at least one shared number, so that's why I changed it. So again, we go through and we box any pairs that we have, so 2 and 2 pair up. And then everything else that's not a pair gets its own box. Okay, so even though we have a bunch of 2's here, we only pair one of them together because there's only 1 2 up here. Now this box becomes its own number, it becomes a 2, and then we'll get 4 more 2's from here. So we have 5 2's all together. Then we get a 5 here, and a 13 here. So now we just have to multiply this number out. If we have a calculator, it's pretty easy. Even without a calculator, let's see, this will be 5 times will be 32. And then 32 times 5, we know that's going to be 160. And so then 160 times 13. In class, of course, you'll be able to use a calculator here. But I don't have one on me at the moment. So 2080 would be the least common multiple here. And again, that took a little while. It took us maybe 2 or 3 minutes, but it probably took us a lot less time to do it this way than to go through and to list out all the multiples of these numbers until we got to the number that was shared between the two. So it's a little more efficient. Even though with the bigger numbers it does take a little more time, it probably takes less time than doing the other method. So that is the least common multiple. Another thing we can look at between numbers is what's called the greatest common factor. And that's exactly what it sounds like. If you take two numbers and find their prime factorization, or I should say maybe not the prime factorization, but if you take two numbers, what is the largest number that is a factor of both? In other words, what is the largest number that will divide into both of those numbers? For example, 45 and 60. I know that 5 will divide into 45, and I also know 5 will divide into 60, but the question is that the greatest common factor that they have? There's a very easy way to do this. If you're good with your prime factorizations, we'll just write this as a prime factorization. So 45 will be 5 times 3 times 3. It's 9 times 5. 60 will be 3 times 20, so 3 times 2 times 2 times 5. Then all we have to do is lasso pairs together. So 3 and 3 are a pair, and then 5 and 5 are a pair. So this is a little different than the least common denominator because we're only taking numbers that are shared between the two. So 3 is shared and 5 is shared, so that means that my greatest common factor is just 3 times 5, or 15. And you can always do it this way to find the greatest common factor. With smaller numbers like these, maybe it's very intuitive and you don't actually have to work it all out like this, but if you have larger numbers, this becomes a pretty quick way to take care of it. So let's try one more example. So how about 124 and 64? What is the greatest common factor of these two? Well, again, I'm just going to break each of these down into their prime factorizations. So 124 is really 2 times 62. 62 will continue to break down into 2 times 31. And then 31 is a prime number, so it won't break down anymore. So that's as far as we can go with this one. So 124 is 2 times 2 times 31. 64 breaks down into 8 times 8, and then each of these 8s breaks down into 3 2s, because 8 is 2 times 2 times 2. So really 64 is just 2 times 2 times 2, 6 times. So again, I just go through and lasso whatever is the same. So there's a 2 that's the same here, a 2 that's the same here. That's it. So I get 1 2 from that lasso and 1 2 from that lasso. So my greatest common factor is 4. It's not very big. Maybe we were expecting a little bit bigger number, but in this case, the greatest common factor is 4. This is the biggest number that will divide into both of these numbers at the same time. So something like 8 will divide into 64, but it won't divide into 124. And that's what we're doing here.